Hi humans, Anna Gray here. If you are like me, you just got off for your holiday break, but don't get too excited or relax just yet because if your university is scheduled at all like mine, you have finals coming up. Yay! So today and for the next couple days, I'm going to be going over some review concepts, some of the um, statistical concepts that I think are most important to review. And this is going to be, hopefully, this is going to help me and aid me in my studying, and hopefully, it'll provide some benefit to someone. Again, if there's anything that you would like to see, please comment below and let me know. But today we're going to be looking at finding the critical value for the z interval for the true mean. So we're going to find the critical values or show you how to find the critical values for an 80, 90, 95, 98, and 90%, 99% confidence interval for the true mean. Now, if you are a stats fanatic, you may have these percentages, these confidence intervals memorized. You may know that an 80% confidence interval for the true mean is z critical being 1.28 and a 90% is 1.65. You may know that. But the goal here is to be able to calculate it yourself. So if the question asks you to find a 78% confidence interval for the true mean, finding the critical value of the 78% confidence interval for the true mean or 91% confidence interval for the true mean, that you know how to calculate it. Or when you look at the 80 or 90% and you know the value, you know how the value was calculated. So I'm going to go through the calculator TI-84 instructions, which are super easy, and then I'm going to also draw on the bell-shaped graph, get a little visual, and my drawing skills are terrible, especially on the tablet, so please bear with me as we go through this. But we're going to start with our 80%. So we're going to start with the 80% confidence interval for the true mean. And the level of confidence, okay, is the area below our bell-shaped curve that's locked in by our critical values. So I'm going to go on ahead and put those here. Okay, so these are our critical values that are locking in our 80%, which is our level of confidence area. Okay, so this is going to be our negative z. This is going to be our negative z. And this is going to be our positive z-score. Okay, so negative z and z. And these values separate the probable sample statistics from the improbable. Basically, they tell us our rejection region. So, let me see. This area right here and this area right here, these are our rejection regions, the regions to the right and to the left of our z-scores. So the level of confidence tells us the probability that the interval that we have has the parameter. So it's the probability that this area right here, all of this, please excuse that terrible drawing, but all of this here in the middle, I'm just going to go ahead and color this in. That all of this green area has the parameter that we are looking at. Okay, so I'm going to erase all that. Okay, here we go. So we know that our confidence interval is 80%. So we know that our confidence interval is 80%, our level of confidence. Okay, so that is the value. This is our C value, and it's going right in here, and it's constrained by our two z-scores. So we know that the total area underneath the curve is 1 or 100%. So you can either do 100% minus 80% to get 20%, or you can do 1 minus 0.8 and you're going to get 0.2. Divide that by 2 because we have 2 tails and they are equal, and we get 10%, or 0.1. So we know that the area in each of our tails is going to be 0.1. 0.1. So we know that if we use the z-table, it's going to tell us the area below our z-score. So, another color. What's that orange here? Okay, so we know that if we're trying to find our negative z, we're looking for the area below negative z. And that's easy because we just calculate that. We know that it is 10% or 0.1. So we're going to go to our z-table, and we are going to try to find 0.1, or the value that is closest to it if we can't find the exact value. Okay, 0.07, 0.0934, 0.0951, 0.0968, 0.0985, that's getting close. 0.1003, that is over. Okay, so we know that our level of confidence falls between these two values in our z-table, 0.0985 and 0.1003. Now we need to find the value that is closest to our level of confidence. Now, visually, we can see that this is closer. This value right here is closer. 0.1003 is closer. But just for the sake of doing the math, in case it's not so obvious, we're going to do minus 0.0985, and we're going to get 0.0015, and then this critical value, this level of confidence, sorry, this is not the critical value, this level of confidence is above. So I'm just going to take that and subtract our 0.1, so 0.1003 minus, you guys see what I'm talking about my handwriting? It's terrible. And we're going to get, this one is smaller. So this is the level of confidence that we are going to go with to find our critical value, our z-critical. So we have this value, 0.1003, and that actually was a little thicker than I would like it to be. So I'm going to make that a little bit thinner. Okay. So we're working with this value right here. So now we're going to work from the inside out. So we're going to draw an arrow to the left, all the way to the left, and we're going to come to negative 1.2. And we're going to draw an arrow all the way up to get the second half of that value. And we're going to see that is 0.08. So add those together, and our negative z equals negative 1.28. Now we know, just based on the principles of the normal distribution in the bell-shaped graph, that our negative z and our z are just going to be negative and positive versions of each other. So we know that z will be 1.28 just by the laws of symmetry. But we're going to go on ahead and go through how to get that one as well, just for a little bit more clarity. So if we go back to our critical values, now we're trying to find, let me see, I'll use a rainbow pen. Now we are trying to find positive z. So we need the area below positive z. So now we need to put the 0.1, we need to add the 10% to the 0.8 to the 80%, and that gives us 0.9. So the area below is 90%. So we're going back to our z-table, and again, that's the value we are going to try to find in here. Okay, get my highlighter ready. Okay, so we got 0.8888, 0.8980, 8997, and okay, 0.9015. Okay, so we can see that our value is between these two values. So we've got 0.8997, 0.9015. Again, visually, we can see that it is closer to 0.8997. So we're going to go draw our arrows. At 1.2, 0.08, I did not circle this. Okay, so then we see that our z is going to be equal 1.28, which confirms that. So now we're going to go back to our diagram, and we're going to put in our z-scores. So 1. Okay, so we've got negative 1.28 and 1.28. These are our z-values that constrain our 80% level of confidence and show us our rejection region. So now I'm going to show you how to do that via calculator because I think it's really important to understand the way to do it that, some people are table people, some people are TI-84 people. So we're going to go through how you would do that. Subtract all this old math. Okay, so you're going to turn your calculator on, standard, and you are going to go, let me see, you're going to click on second. You're going to hit variables. So second, there's. And you're going to go down to option number 3. It's going to say invert norm. And you're just going to hit enter. Now, something on your calculator is going to pop up and it's going to say invert norm, and it's going to have the beginning parentheses. And what we're going to put in this parentheses is the area below the z-score that we are trying to find. So we know that for our negative z, it's going to be 10%. So we're going to put that in to our calculations. And we get 1.281551567, which rounded, which rounded to our 2 decimal places is going to be negative 1.28, which checks out. So now this value checks out by calculator and by z-table. So now if we do our upper z-score, our positive z-score, if we do invert norm, and we put in again that area below, so that's going to be that 90%. We are going to get positive 1.2815551567, which again rounded to 2 decimal places is going to be 1.28, which again checks out by calculator and by hand with the z-table. So these values won't always be exactly equal. Obviously, the calculator is more accurate. It is a computer, and the z-table, a lot of times that we're guesstimating or we're just getting close. But both of these methods can be used to find the critical value for the z-interval for the true mean. Again, I hope this video was helpful, and I'm going to go on to make other videos showing the 90, 95, 98, and 99% confidence interval for the true mean, as well as looking at t-scores, t-intervals, chi-square tables, all those kind of things. So if this is something that you're interested in or you just want a little bit more review with, definitely tune in, and thank you guys so much. Thank you.